this video, we are going to design a 8:1 multiplexer using system Verilog. An 8:1 multiplexer is a digital circuit that selects one out of 8 input signals and sends it to a single output based on a 3-bit control signal. There are 8 inputs, let's call them I0, I1, I2 to I7 and 3 control bits S2, S1, S0. Only one output Y. Now we are going to use EDA playground for this simulation. First we are going to write the test bench code. The header time scale 1 ns by 1 ps. This tells the simulator the time units and precision for the simulation. And then module TB mux 8:1. This line starts the definition of the test bench module and then the signals declaration. First, the logic 7:0, 1. This defines an 8-bit input signal named in that will provide the 8 inputs to the mux. And then logic 2:0, SEL. This defines a 3-bit signal called SEL that represents the select lines used to choose which input is passed to the output. And then logic out. This defines a single bit out to hold the mux output. And then instantiating the mux. This section creates an instance of the 8:1 multiplexer module named UUT, which stands for unit under test. The inputs and outputs of the mux are connected to the corresponding signals in the test bench. And then the dump file mux8:1.vcd. This tells the simulator to create a waveform file named mux_8:1.vcd. This file can be used to visualize the signals during simulation. And then the dump verse line tells the simulator to record the changes in all variables inside the module for waveform analysis. And then applying test cases, the 8-bit input pattern is set to 10101010 for all tests. SEL equal to 3 quotation B000 to SEL B111. The select lines are varied from 000 to 111 to test each of the 8 inputs in sequence. And then the hash 10 introduces a delay of 10 time units between each test case. And then the finish line tells the simulator to stop running once all test cases have been applied and the simulation is complete. Now we are going to write the design code module mux8:1. This starts the definition of the module named mux8:1. Input logic 7:0 in. This defines an 8-bit input vector called in. Input logic 2:0 SEL. This defines a 3-bit input called SEL, which is the select signal. Output logic out. This defines a single bit output called out. And the always block specifies combinational logic. And this is a case statement that checks the value of the select signal. Depending on the value of SEL, it selects which input is passed to the output. If none of the values from 000 to 111 match, the output is set to 0. And the end module marks the end of the mux8:1 module. Before running the code, you have to select the tool and simulator as iCarrier's Verilog and select Open EP Wave after run. And run the code, the waveform will be generated. And this is the expected waveform for the 8:1 multiplexer. Now we will see the explanation of the EP wave. The in signal remains constant for the entire simulation. The SEL signal changes every 10 nanoseconds, moving from 000 to 111. When SEL equal to 000, in 0 is selected, so the output is 0. When SEL equal to 001, in 1 is selected, so the output is 1. This continues for all values of SEL until SEL equal to 111, which selects in 7. And that's how an 8:1 multiplexer works in system Verilog. We wrote the design code, created a test bench and saw how the mux selects one input based on the select lines. In the waveform, you can clearly see the output following the selected input perfectly. Thank you.